Hello students, it is time to move into the second module of Energy 301/ATS 564, and this is the module in which we're going to start learning about the basics of programming and how we're going to be using programming to start modeling electrical load and yield, the name of the class. And before we can actually start working with programming, we need to get this idea about operating systems under control. We're going to be working with a very different computer and very different operating system than most of you are familiar with, and so let's kind of get that under control and understand what we're talking about here. But just so we have kind of a target here, so we understand where we're going with all of this, we're going to be writing computer programs in a language called Octave. And we're going to be doing this on a remote computer, a computer that's actually physically here in my office in Indiana. Because this kind of modeling work is invariably done like on your laptop. You're going to be at your laptop or at your desktop computer writing the programs, but you're going to be connected to a remote server where you're going to be actually testing your programs and doing the calculations. And that computer, which is physically here in my office and goes by the name Chesapeake, is actually running an operating system called Linux, which most of you are not familiar with, but you're going to be very familiar with by the end of this module and certainly by the end of the course. It's actually, by the way, a specific version of Linux that is called Ubuntu, but again, we'll talk more over the course of the module and so on about all the different versions of Linux and so on. So we're going to be able to do things like model electrical load and yield. Like, for example, in the third module of the course, you're going to be using these skills to write a program that predicts the amount of electrical power available to a solar panel under different conditions, like different days of the year and different latitudes and things like that, different angles that the solar panels are sitting and so on. And you're also going to be able to perform statistics on very large data sets. But in order to do this here, we want to get familiar with this idea about operating systems, okay? Because this computer that you're going to be using is not running Windows, it's not running Mac OS X, it is running a different kind of operating system called Linux. And this word operating system is something that, people kind of use. I mean, I've even heard my mom use the word operating system, like when she had to upgrade the operating system on her iPhone. But that doesn't necessarily mean that we're all clear about it. And so, just as a shot in the dark, I decided to just Google define operating system, and I got this, I don't hate this definition, that it is the software that supports a computer's basic functions, like scheduling tasks. This isn't necessarily like as in your scheduling that you have an appointment. I mean scheduling the tasks, like what's going on the chips of the computer, how it decides when it's going to do this and when it's going to do that. Controlling the various processes that are at work, what's going on in this window, what's going on in that window, etc. Executing applications, controlling all the devices and peripherals that are set up on the computer. That's, fundamentally what an operating system is doing on any kind of electronic device. And in your lifetime, you have worked with lots of different operating systems on computers. I mean, some examples of operating systems would be things like Windows or Mac OS X. They would be things on your mobile devices like Android or iOS. Or they could be things like Linux and Unix. Unix, we'll see, Linux is a type of Unix, but we'll get there. We're going to actually kind of take apart the whole family tree of these different kinds of operating systems. Let's talk, though, about, because it's kind of useful to have this, so we can do some comparison and contrasting here. Let's talk for a minute about Windows. Relatively recently, Windows 10 came out, and everybody's all excited about the possibilities of what it can do different than previous versions of Windows. But let's be clear about what Windows is. Windows is a product. It's made by a company called Microsoft. I'm sure you knew that. It's completely patented and trademarked and copyrighted and all of that. It is a corp company secret how it works. You cannot go someplace on your computer and find like the program. There is no, like you can find the C program behind Windows or something like that. You can't see the code. God forbid you can't modify the code. Okay, how Windows works, you can't go and make changes to it or make it work better or make it work differently or anything like that. And you certainly can't do anything like distribute the code. I mean, even though you've paid for a copy of Windows, you don't own it. You just have a license to use it. You can't make changes, you can't give it away, you can't sell it. You don't own it. You just have license to use it. And the current iteration of Windows, Windows 10, is the latest in a very long series of products that Microsoft has been selling, for 30 plus years at this point. Starting with all the iterations of DOS way back when in the 80s. And, they got up to like DOS 6 or something like that before they started selling Windows. And Windows 1 and 2 kind of disappeared. You never really saw that very much. But Windows 3.0 came out in like 1990. At some point there was Windows 3.1, and then they switched to using that model year naming system, so you've probably had some experience with like Windows 95 or Windows 98. At least you saw it on your grandparents' computer or something like that. At some point they switched naming systems and went to like Windows XP in about 2001, Windows Vista in about 2005. Then they switched naming systems again, and somewhere around 2008 or so they had Windows 7, followed by the very strange and futuristic looking Windows 8 that was very cool looking on tablets but a little hard to use on your desktop. And recently they've skipped Windows 9 and moved on to Windows 10. This is their main consumer family of operating systems. They also had products that were more oriented around like corporate use for like servers and things like that. There's like Windows Server 2003 and Windows NT 4.0 and things like that that are related products to this long family history of these copyrighted operating systems by Microsoft. They're designed to run on Intel-based computer chips, and they took over the world. These are by far the most popular operating systems. Well, maybe. Certainly in the 80s and 90s and early 2000s, these were by far the biggest amount of computers out there, or at least of the computers you've seen. But we'll set that into some context in just a few minutes. Okay, let's move on and talk a little bit about the Macintosh operating system, or Mac OS. Now, my guess is most of you are somewhat familiar with Mac OS 10. I mean, that's the version of Mac OS that they've been on since like 2001 or something like that. But let's talk about before they hit Mac OS 10. Older versions of Mac from like, that started in like the mid-80s, roughly 1984, didn't look very much like what you're used to. I mean, yes, they looked a little bit like Macs is what you're thinking of today in the sense of like, you know, there were windows and drop-down menus and so on, but the whole thing was very, very different. The current Mac OS operating system is actually unrelated to what was going on back in the 80s and 90s. Apple released a whole series of sequentially numbered versions of Mac OS. You know, there was a Mac OS 2 and a Mac OS 3, all the way up until they hit Mac OS 9. And so there was, you know, gradual improvements and so on in Mac OS over a period of about 15 years or something like that. But by the late 90s, Apple basically went out of business. You know, it's now, of course, they're one of the world's largest companies. It's hard to believe how bad the situation was for Apple. But Apple had effectively zero market share by about the mid-90s. Macintosh computers had all kinds of problems that were just making them completely uncompetitive, especially in their own space. You know, the markets they were going for, like artists and schools and things like that. You may know, of course, that, you know, Apple was founded by Steve Jobs, but you may or may not know is Steve Jobs was actually thrown out of the company, early 90s or something like that, and the company just got worse and worse and worse until he came back in the late 90s, early 2000s. But before that time, all these Mac OS 2, 3, 4, 5s or whatever, they were also, much like Windows, they were a product, a fully copyrighted, trademarked product, the intellectual property of Apple Computers Incorporated. And again, you licensed, when you bought a Mac, you licensed that you were using Mac OS 6 or whatever version you were using, but you couldn't like go and mess around inside your Mac and find the code. There was no Mac OS 6.c that was the C program that is running that. I mean, that code is all locked down. It is corporate secrets of Apple Computers Incorporated and so on. You could certainly not make any changes to it. I mean, you could change your background and you could change the colors and so on, but you can't change the operating system. If something wasn't working right, you just waited until they released the next version of the operating system. You couldn't fix anything. You might think, I own this copy of Mac OS 6, I should be able to distribute it. No, you don't. You don't own it, you're just licensing it. Mac OS, prior to Mac OS 10, was a product. It was the intellectual property of Apple, and it had certain advantages. There was a reason why artists and schools and so on were using Macintoshes in contrast to the Windows computers of that time. In particular, Macs, those earlier Macs, the Mac OS 5 and 6 and so on, they actually ran memory hog programs better than the Windows computers of the time did. This would be, like if you were producing video or you were running something like Adobe Illustrator or Photoshop, programs that took, at least by the standards of the time, a lot of memory. Back in the era when computers had 1/100th as much memory as they do now, Mac did that better than Windows back then. So if you were like an artist and you were producing video, or you were an artist and you were, doing graphic design or something like that, a Mac was a good choice for then. And certainly was the case that Macs looked better. Mac OS 6, Mac OS 7 certainly looked better than early versions of Windows 2. It was more consistent, it crashed less, it had less problems with viruses back then, and so on. But the business model was terrible. By about 1993, 1994, Macs were just ridiculously expensive for what they got. A Macintosh in about 1994, 1995 might have cost you $4,000, $4,000 or $5,000. In 1994 dollars. In contrast, for example, a new car in 1994 would have been about $8,000 to $10,000. Okay, if you're spending half as much money on your computer as your car, there aren't going to be very many people who are going to be willing to spend that much money. Macintosh had such an incredibly small market share back then that software was always released for Windows computers long before, if ever, for new versions of the Mac operating system. I mean, Mac's bread and butter back then was the programs like Photoshop and Illustrator that like professionals in graphics design were using, but even by the mid-90s, those programs always, updates to Photoshop, updates to Illustrator, they always came out for Windows months to years before they came to Mac. I mean, the market share was just too small, it was too expensive, and by about 1997, Apple was effectively out of business. Steve Jobs was long gone. They had basically no market share. Things got different with Mac OS X. We'll get to that in just a little bit. But before we move into what that is, I want to talk about Unix. Unix is another operating system, and Unix is a very different model. Mac OS X, or Mac operating systems in general, are designed to run on Macintosh computers, whatever hardware they're using at that time. Windows operating systems are designed to run on the kind of computers that are built by Intel. Well, the chips are built by Intel, or by clones like AMD. Unix is specifically designed to be relatively easy to move to different kinds of hardware. Okay, if somebody builds such a chip, it's not that big of a deal to get Unix to run on that chip. So like lots of smart devices, like cell phones and routers and things like that, run Unix as the operating system because it was relatively cheap and easy to get Unix to run on that chip. Okay, that is what Unix does very well. The amazing thing about Unix as an operating system is it isn't owned by anybody. Unix is not a product, it is not owned by any company, it is not owned by anybody. It was written over a period of many, many years by grad students and hackers and programmers during their off hours and so on. It is a standard. It is a set of rules as to how operating systems should work. It isn't owned by anybody, though. Nobody owns Unix, and anybody who wants to can get a copy of anybody else's Unix, change it, modify it, improve it, fix it, and distribute it. If you want to make a version of Unix, if I want to write a new version of Unix, which I'm going to call John OS, I can download a copy, I can make whatever changes I want to. If it's good changes, I can give it away, I can sell it, it doesn't matter. Whatever I want to do with it. You can see how this puts huge pressure to make Unix better and better all the time, right? Anybody who wants to find a way to improve it can, and they can do whatever they want to with it, from sell it, to give it away, to wait for somebody to make it even better. This, on the other hand, also leads to a world in which there are zillions of different varieties of this Unix operating system. For example, lots of varieties of Unix are made by companies for the computers that they build. For example, again, these are operating systems you would probably never actually see in your day-to-day life, but for example, IBM, for their line of servers and things like that, they distribute an operating system called AIX. It is a version of the Unix operating system that runs on the chips they build for their servers. The same is true, for example, Hewlett-Packard makes a operating system that is a version of Unix called HPUX. And HPUX is an operating system that runs on the servers that Hewlett-Packard sells. There's another one called Solaris. Solaris is a version of Unix that has been set up to run well on the servers that Sun sells. And there are lots of these kinds of things, one of which being Mac OS X. Mac OS X is a version of Unix. It is a version of Unix that Steve Jobs' software engineers downloaded and modified to make Mac OS X. It runs on the chips Apple manufactures. It runs on the motherboards Apple manufactures. To make Mac OS X, starting in about 2000 or whenever the first version of Mac OS X came out, Apple gave up. They had spent 15 years developing Mac OS 2, Mac OS 3, all the way up to Mac OS 9, and they said, nobody's buying this. Let's just get rid of it. And Steve Jobs came back to the company, and he brought back with him Mac OS X. But all they really did was download Unix, an operating system that runs on lots of different kinds of computers, and then they just modified it, which you can do. Anybody can freely make changes to Unix. All the programs that make up Unix are there. And most of the changes that this Apple Computers Incorporated software engineers made were mostly to make it look like more of a Macintosh product. They changed the icons, they changed the animations, they moved the menu bar from the bottom to the top, things like that. They made it look more like a Macintosh. But under the covers, they didn't need to change it. They didn't really need to change it, because Unix had already been around by then for probably 30 years, and had spent 30 years being improved and improved and improved and improved by hackers and grad students and software engineers and so on. They didn't need to make it less, more stable or better at memory management or faster at controlling peripherals or something. That all had been done for 30 years already. Alright, so Mac OS is just a type of the Unix operating system. And you know what else is just a type of the Unix operating system? iOS. iOS, what runs iPhones and iPads, and I don't even know, are iPods still a thing? iOS is just a type of Mac OS. They just started with Mac OS X and made changes for it to run on a smaller screen and so on. But you know what? If you could jailbreak your iPhone, you can get in there and actually start looking around the kinds of things we're going to see in our classes here. You'll see all the files that we're going to be using, you'll see the tools that we'll be using, etc. are all there on your iPhone. You have to jailbreak it to get to those features and so on, but they're there. Same, by the way, with watchOS on Apple Watch and so on. They're just varieties of Mac OS, which is just a variety of Unix. But there is one variety of Unix that kind of took over the world, and that's Linux. Linux is what we're using in this class. Linux is just a type of Unix. It's related to all these other operating systems, but it was a different idea. See all those other types of operating systems up there? AIX, HPUX, Solaris. These are operating systems that were distributed by IBM, HP, Solaris. There were other companies like that that made servers and so on. But here's the deal. They didn't sell very many of those. An IBM server to run, the databases at, the IRS or something, it might cost a couple $100,000. They don't sell very many of those. There's no economy of scale. If IBM could sell millions and millions of those servers, the price would come down, but the price never comes down because they don't sell that many of them. But there was one segment of the market where the price had come down to basically nothing, and that was PCs. I mean, because there are literally billions of PCs out there, those kind of chips made by Intel and by AMD and other cloners and stuff like that are everywhere. The world's awash in those chips. They're basically free. I mean, yes, they cost something, but they cost practically nothing. So, Windows was popular making these chips so cheap and so easy and so readily available that you could get PCs cheaper and cheaper and cheaper. And these PCs were not that much less powerful than these multi-$100,000 machines that IBM or Sun or HP was selling. This is where a brilliant engineer named Linus Torvalds stepped in. Linus Torvalds is I think he's Dutch, and he came up with this idea that what we really needed was a version of Linux. Heck, he even was clever enough to name it sort of after himself. His name is Linus, and he calls it Linux. It's a version of Unix that runs on cheap Intel computers. Okay, computers based on Intel chips or AMDs or whatever. He specifically made his version of Linux particularly powerful. He put all the most powerful tools, we'll learn about the kinds of tools that are part of Linux over the course of the semester. He made sure all the most powerful tools were there. He wanted it to be really reliable. A Linux computer, he wants you to turn it on and it can run for months. Okay, no crashing, no anything like that. And he wanted it to go on the cheapest of the cheap. He wants you to be able to buy any piece of junk, cheap computer, take grandma's old computer that she doesn't use it anymore out of the garage, and Linux should run on it. Not surprisingly, that is a big idea. Okay? If you can make an operating system that is super powerful, super reliable, and runs on the cheapest of the cheap, you're going to take over the world. Might not seem like it because you're thinking, gosh, I've never used a Linux computer. Sure you have. You just didn't know it. There are lots of Linux computers in your day-to-day life. Android. If you have an Android cell phone, Android is Linux. Because Linux is a type of Unix, nobody owns Linux. The engineers at Google downloaded a copy of some version of Linux and made changes to it to run on a little screen that runs in your pocket. Okay, it's a special version of Linux that is optimized to run on those kinds of chips made by companies like Snapdragon and things like that, and to run on very low power because they don't want to drain the battery and things like that. It's a special version of Linux, but it's just a version of Linux made on cheap computers. Okay? I mean, your cell phone does not seem cheap, but when you think about all the technology in there and compare it to a $400,000 IBM PowerBlade server, yeah, it is cheap. Okay? The particular version of Linux that we are going to be using in this class is actually a version called Ubuntu. Ubuntu is a Swahili word, I believe, that means something like human. Okay, it's a particular version of Linux that's a little bit easier to learn and has a few, it's easier to set up accounts and things like that. That's not so important. Another version of Linux you may have encountered in your day-to-day life is Chrome OS. You may know somebody who has like a Chromebook or something like that. Chrome OS is just another version of Linux. This just keeps happening. Somebody else, again, no one owns Android. Android is a type of Linux, which is a type of Unix, so nobody owns Android. Google does not own Android. Google's in charge of Android in the sense that they try to get it all steered so all the companies use it the same way and so on, but Google themselves don't own Android. So other companies have gladly just downloaded Android and made changes to it. The most famous of that would be Amazon Fire OS, like what runs Kindles and things like that, or Fire Sticks on your television and stuff like that. But if you were in other parts of the world, in particular like in Chinese and Japanese markets, there's other phone operating systems than just Apple, iPhone, iOS, and Android phones. There's these other manufacturers that make knockoff versions of Android and so on. Actually though, Linux is everywhere. You got a little box that runs your television, like I have a Roku that runs my television to like download and stream Netflix and stuff like that. That runs Roku OS. Roku OS is just a version of Linux, which is a version of Unix. So nobody owns Roku OS. If I wanted to download it and hack it and make a better version and sell it, I could. Alright? But we're going to be focusing, in this class, we're going to be using the Linux operating system on a computer here. And as it happens, the particular version of Linux that we're using is Ubuntu, but actually from your point of view, like, you know, if you then went and used a different computer in a different class and they were using a slightly different version of Linux, you wouldn't be able to tell the difference. I mean, Ubuntu is close enough to a standard that you're not going to, we can call this Linux and it's fine. Why? Why do scientists do this? Why do they use Linux in contrast to other alternatives? Why don't scientists run their computer models on a Windows computer? Or why don't they do their big calculations on a Mac or something like that? Well, for one thing, Linux is generally free or cheap. In this class, you're going to be logging into a computer that's physically here in my office called Chesapeake. It's a Linux computer. It's running Ubuntu. I didn't pay anything for Ubuntu. I downloaded it for free. Not like I did something wrong. It is free. And the computer itself is about a $450 Intel, it's a Lenovo for what it's worth, a Lenovo Windows PC. It shipped with Windows 7. I had to erase Windows 7 to install Ubuntu Linux on it. For like $450, I've got a beast of a machine in my office here that I can get lots of people working on and so on. It is free or cheap. And it is generally pretty reliable. I mean, I have installed Ubuntu Linux on computers I found in people's garages. I'm a pack rat when it comes to that kind of stuff. It runs on practically anything. It is generally a very light operating system. It performs calculations faster than like the same kind of programs would run on a Mac or a PC. The kind of programs that do lots of big calculations, like weather simulation models or climate models or whatever, you can't run something like that on a Windows PC or on a Mac. It would take forever. Okay? Generally speaking, Linux computers are very much faster. Linux has been... let's explain that. Hackers and grad students and software engineers in their off time have spent the last 40 years improving Unix to make it incredibly efficient in terms of how it uses the chips to squeeze every little drop of power out of them. That's not exactly what happens behind closed doors at, say, Microsoft. Okay, they're not exactly in the business of making every single thing do the best number crunching possible, because frankly, number crunching isn't what you do that much on your PC, okay? Your PC is doing other things, and doing them well, like, you know, controlling the scrolling, making it smooth, or recognizing your voice in Cortana or Siri or something like that. You know, that's all powerful stuff, but it's not number crunching, okay? For powerful, doing lots of number calculations, you can't beat a Unix operating system like Linux. Linux operating systems are also designed to have multiple people logged in at the same time. There is a limit to the number of people who can be logged in at a given time on a Linux computer, but I think it's in the hundreds of thousands. You could literally have hundreds of thousands of accounts. Now, don't get me wrong, the network speed would become a problem, but it's certainly not going to be any problem that the, like 10 of you, or however many are in this class this semester, are all logged into Chesapeake, my Linux computer, at the same time. That's not going to be a problem at all. Okay? You can all be logged in and all working on a computer from 600 miles away, and it's just like you're there. Okay? It's designed for that. And so, part of the reason why that's going to work, though, is Linux is designed to not need to have a graphical user interface. Mac OS, Android, iOS, Windows, all these operating systems now, you have to run it with its graphical user interface. It has to be clicking or touching and icons and swiping and drop-down menus and scroll bars and all that. All that has to be. You're not using Windows if that's not there. You're not using iOS. You're not using Android if that's not there. Linux isn't like that. The graphical user interface is separate and doesn't need to be running. So when you log into Chesapeake, our Linux computer for this class, from your laptop, and you'll be learning how to do all that, you're not going to have Chesapeake also working, you know, it's not going to be showing you icons and stuff like that. It's just text on the screen, and you're going to use the command line interface to type in commands like that you're going to be running Octave, and that you're editing this file, and things like that. You'll be learning about how to do that all in this module. Well, if your computer isn't spending time doing things like displaying icons, keeping track of the cursor, where the mouse is, handling all the animations and so on, think of all that power that is being used for something more productive, like crunching numbers for you. Okay? We could easily run weather prediction models and so on a computer like Chesapeake, because it's not spending so much of its time on fancy schmancy graphical user interface. Okay? Another reason why we tend to use Linux operating systems is they are extremely secure and reliable. Again, 40 years of hackers working on these operating systems late at night, sitting around drinking a Mountain Dew while trying to rewrite this piece of code, has made Unix a tank. Okay? It is impenetrable. Nobody's going to hack Chesapeake. Okay? Well, they might hack it if you aren't careful about your password, but I mean, they won't be able to break into it. It is incredibly reliable. I have never crashed a Linux computer in my life. They just don't, I mean, they're just incredibly reliable and incredibly secure. Another set of reasons as to why we use Linux is all the tools exist already there. We're going to be learning about computer programming languages, and these programming languages are all already on a Linux computer. If you look at your Windows computer or your Mac, if you want to write a Fortran program on your PC, there's no way to write, there's no Fortran compiler, to use the right word. There's no way to translate a Fortran program into something the computer can actually do, anything the computer can actually execute on that computer. Windows doesn't ship with things like that, and in fact, if you want something like that, you have to pay for it. Okay, you can download it from the Windows Store. I don't know about Fortran, but in general, other computer languages, including Octave, you could get Octave for your PC. Don't. We're going to run it on Chesapeake rather than on your PC. Same with Mac. Okay, I mean, all these different languages and stuff, the kind of tools we're going to be using, things like command language interpreters, compilers, editors, debuggers, web servers, file transfer software, image manipulators, all these kinds of tools that we're going to be using, they all already there on Linux. Okay? They don't ship with a web server on your PC. They don't ship with a web server on your Mac. They do on Linux. They ship with all these editors to manipulate your files, all these tools for managing large databases. It's all already there. I just downloaded it, burned it onto a DVD, and stuck it in the machine while drinking a Mountain Dew. Okay? I didn't have to do all the work to install that stuff. What a great tool. No wonder Linux turns out to be the right tool for the job when the job is science. Scientists love this kind of stuff. It's all already there. It's already set up. It is cheap. It is powerful. It is standard. I can go to a different Linux computer and it's all the same. And it is great for collaborating. I can put all of my students on the same computer and we can all be sharing the same tools. Linux is the right tool for what we're doing in a class about modeling electrical load and yield. Alright, so we're ready to learn more then about, in general, about working with computers and languages and so on, which is what we're going to do in the next lecture before you actually are then shown how to actually get onto our Linux computer, Chesapeake. Alright. Please let me know if you have any questions. This has been Dr. John Schrage.